Where would we be without laboratory glass? A material refined across centuries of invention and reinvention. Glassware is a marvelous accomplishment, born of sand, made molten through fire, blown or poured, shaped by science for science. I've always been amazed by glass, by its efficiency of design, its nearness to perfection. I say nearness because glassware is so fragile. If glass is bumped or dropped, or if too much pressure is applied to it, it can easily become glass soup, and we can be hurt in the process.
Some accidents don't require much more than a Band-Aid. Others mean a lot of blood and a doctor's needlework. In many cases, the threat of contamination from the materials in the container must also be considered. So how do we protect ourselves from glassware accidents? Well, we learn our equipment, inspect it before use, and follow proper procedures. Glass is everywhere. Beakers, flasks, bottles and jars, tubing, stirrers, pipettes, watch glasses and funnels, all made of glass and all fashioned for specific purposes. It's important that we use them only for those purposes. Makeshift apparatus is unstable and leads to accidents. Evaluate the compatibility of glassware with the chemicals you're using, particularly for work involving acids and alkalis. Many of these react with glass, causing damage and contamination. Remember, only certain grades of glassware are capable of standing up to the lab environment. Use only recommended equipment. As we all know, glassware is often heated to extreme temperatures. Inferior or flawed materials can shatter and crack, showering the area with broken glass and hot chemicals. Never involve glassware in vacuum operations or gas-producing reactions unless it is specifically designed to take the beating. We'll talk more about this later.
Before our work begins, we must always check our tools. Inspect glassware for flaws, tiny star cracks, chips, nicks. If defects are detected, the glass should be pulled from service and discarded, or sent out for repair.
Proper handling of glassware is also important. Never carry a flask by its neck or a beaker by its side. The weight of the container or its contents can crack the glass. Always use two hands, one underneath to support the weight. Gloves must be worn when glassware is handled, assembled, or washed. Of course, it's best to choose cut-resistant gloves that still allow for a high level of dexterity. Stainless steel mesh gloves provide superior cut protection. These, however, cannot be used when a near-perfect sense of touch is required. Wear lab gloves underneath to keep out chemicals. Insulated gloves should be used for work with hot or extremely cold glass. Many people, without thinking, pick up hot glassware, and the glass often ends up hitting the floor. Remember, hot glass stays hot for a very long time. Be careful. Never heat or cool glassware unless it's designed to take the temperature change. Round-bottom flasks are recommended for boiling liquids. And never set hot glass on a cold benchtop. The temperature difference can crack the glass. Even tiny scratches we put in glass can grow to be cracks later on. So don't use a glass or metal stirring rod to scrape residues off glassware, unless the rod has a protective covering. You should avoid any physical stresses to glassware. Where necessary, stabilize it with clamps and platforms to keep pressure off vulnerable points. Ground glass joints are finely crafted for a perfect fit, so perfect that they sometimes stick. Never attempt to force a joint free. The glass may shatter from the stress. Instead, during setup, remember to lubricate the ends to be joined, or use a Teflon sleeve if compatible with chemicals. And later, if some sticking occurs, use a heat gun to gently loosen the frozen joint.
Now we need to look at glass tubing, specifically the cutting and bending of it. We wouldn't have to go over this, but we humans seem to be prone to taking thoughtless shortcuts.
The first step in cutting tubing is, of course, to double-check your gloves and safety glasses. It is important to wear them at all times. You should next position a triangular file and with a single, light stroke, score one side of the tube. Place your fingers right up to the score mark with the score facing away from your body. Gently pull the ends of the tube towards you, snapping the glass at the mark. Remember to fire polish the ends of the tubing. This removes sharp edges and keeps cracks from appearing. In order to bend tubing, heat the material in a flame until it turns red and is soft. Then pull the ends towards you to form the desired angle. Some setups involve pushing a tube or thermometer through a cork or stopper. This should also be approached with caution and common sense. First, determine that the stopper holes are the correct size for the tubing. Then, lubricate the hole and tube end with water or glycerin. Hold the tubing close to the insertion point with a towel and gently twist the tube into the stopper. Keeping your fingers near the end of the tube cuts down on torque stress. This helps to keep the tube from shattering. Remember those all-important gloves. When stirring materials, make sure that electrodes, tubing, and thermometers are placed high enough to avoid the stir bar. If the stir bar makes contact, the whole assembly could shatter.
Some glassware may present unusual safety risks. Work with separatory funnels, for instance, can involve venting under exceedingly high pressures. Make sure you've had all the necessary training before working with specialized equipment.
Vacuum operations can severely test the quality of your glassware. Container walls must be able to withstand the difference between the pressure inside and outside the vessel. Otherwise, the container will implode, sending glass and materials flying. What type of glassware is suitable for vacuum operations? Only round-bottomed or thick-walled flat-bottom flasks, designed for reduced pressure. Glassware showing repairs should be avoided. It's more apt to break through thermal shock. Checking for flaws here becomes of critical importance. The smallest scratch can cause problems. All vacuum apparatus should be placed behind a blast shield to keep containers from being bumped and prevent injury if an implosion occurs. Personal protective equipment is a necessity. Wear goggles and gloves for all vacuum operations. A face shield is also recommended. Flasks, dewars, and desiccators should be covered in tape or mesh to keep broken glass from scattering if an implosion occurs. Tape the glass in a grid pattern so the contents are still visible. An alternative to taping is to use containers coated in PVC. In case of implosion, this coating helps prevent flying glass. Another way to avoid glassware accidents is to replace glass with other materials. Consider using metal, plastic, or Teflon connectors and containers. Remember, though, that plastic can sometimes melt from the heat of hot plates.
More glassware accidents happen during cleanup than in any other laboratory activity. Keep clear of the sides of the sink. You don't want to break something and cut yourself.
Never use a worn-out cleaning brush. The metal holding the bristles can easily scratch and weaken glassware. Avoid cleaning up with aqua regia, chromic acid, or other caustic agents. These are extremely corrosive to the skin and can also present problems with hazardous waste disposal. Small articles may be dried on towels or in lined baskets. Larger containers should be hung on pegs. Remember to store glassware properly to prevent damage. Periodically check that all glass containers are well away from shelf edges. Instruments shouldn't be left to roll around in drawers. Glass bruises, making it more susceptible to cracking. Pad drawers with paper or foam. This will prevent glassware from banging together. Place all glassware well back in the hood or on the bench. This way nothing will be knocked over by hood sashes or passers-by. If a mishap occurs and something is falling, let it drop. You could be injured by breaking glass or splashing chemicals if you attempt to catch it. Use common sense when cleaning up broken glass. Wear leather gloves or heavy gloves with cut-proof liners and never pick up fragments with your fingers. Use a dustpan and broom. Dispose of the pieces in a glass-only receptacle. If there's a spilled substance involved, that material and contaminated broken glass may have to be disposed of as hazardous or biological waste. You should know the correct cleanup procedures. Evacuation may even be called for. Know the locations of eye washes and safety showers, as well as their effective use.
So there you have it, a recipe for avoiding glassware accidents. 10 milliliters each of learning our equipment, inspecting glassware before use, and most importantly, common sense.